Space is far from empty. It's full of debris left over from the creation of the solar system. Asteroids and comets hurtle around the planets and our sun. Sometimes their orbits set them on a collision course with a planet, sometimes Earth. The energy of impact is terrifying. Asteroids and comets have pummeled our planet since the birth of the solar system. But amid the devastation, they may have created the conditions for life on Earth. And they could even have steered the course of evolution ever since. To understand these elusive objects, scientists are sending an armada of space probes to intercept and even land on them. Of all the dangers in our solar system, asteroids and comets pose the greatest threat to our planet. But will we tame them before they destroy us? Some astronomers have made it their mission to hunt for asteroids that orbit close to our planet. And tonight, this asteroid hunter will have a new one in his sights.
Everything about space is interesting, but the asteroids are the closest worlds to us. They're the ones in our own backyard. They're the ones that one way or another are tied to our destiny.
Steve Ostrow is one of the world's leading radar astronomers. He's come to Arecibo in Puerto Rico to use the world's most powerful radio telescope. This 1,000-foot dish, built into a natural hollow, is 3 times bigger than any other on Earth. The moving platform suspended above the dish is both transmitter and receiver. The Arecibo dish can be used like a giant radar gun, except the targets are millions of miles away.
This tells us more about the asteroids than any other instrument on the surface of the Earth. Tonight, we're going to be looking at an asteroid 5 million kilometers away, and we're going to measure the distance to the object to maybe 10 meters.
The giant dish will beam a series of million-watt radar signals to a tiny pinpoint in space. Half a minute later, a faint echo will bounce back from the asteroid, and first contact will have been made. Ostrow's radar images resemble those produced by ultrasound. Ghostly, but surprisingly detailed. Geographus, a 3-mile-long asteroid made mostly of rock. Others are almost pure metal. Ostrow has studied near-Earth asteroids as small as 100 feet across and as large as 15 miles. Radar data produces accurate information about the size and speed of these objects. We now know there are millions of them.
All those objects are near-Earth asteroids. All of them are Earth-crossing. All of them have the potential to intersect the orbit of the Earth. And their existence was not even suspected just decades ago.
The very first asteroid was identified in Palermo, Sicily, 200 years ago. British astronomer David Hughes has come here to celebrate the event. His destination is the old observatory on the roof of the Royal Palace, a landmark in the history of our understanding of the solar system. In the 18th century, this telescope, the Ramsden Circle, was considered state-of-the-art.
It's an instrument of great accuracy and was clearly at the forefront, and a telescope which is worth travelling distances to look at just for its own beauty.
This telescope was to change the map of our solar system forever. Astronomers were suspicious that there was a missing planet between Mars and Jupiter. Then, on the 1st of January, 1801, Italian astronomer Giuseppe Piazzi discovered a new heavenly body by accident. He was producing a star catalogue, checking the positions of stars in the constellation of Taurus. Piazzi found what he thought was a new star. The next night it had moved, and he realized it must be something else. As the months progressed, it seemed to follow a roughly circular orbit. Piazzi announced he had found the missing planet, and he named it Ceres, after the Roman goddess of Sicily.
Ceres was expected because people realised there was a gap in the solar system between Jupiter and Mars. But Ceres was faint, not a real planet. And then, after 1801, people discovered other bits in this gap.
What Piazzi had discovered was an asteroid, a 500-mile-wide piece of debris left over from the birth of our solar system. When our sun was born, it was surrounded by a swirling disk of thick gas and dust. The dust accumulated and eventually formed the inner rocky planets. But the material between Mars and Jupiter didn't form a planet and remained as fragments.
There was enough material to form something 4 times more massive than the Earth. But during this growth process, Jupiter perturbed the bits. Instead of coming together to form something bigger, they started smashing into each other. And what we now see is just a huge collection of fragments in this region between Jupiter and Mars, the asteroid belt.
Beyond the orbit of Mars, over 100 million miles from Earth, the asteroid belt contains thousands of huge asteroids in an ocean of smaller rocks and fragments. Until recently, few scientists imagined that anything from out here had ever come within striking distance of our planet. Then we began our exploration of space. The craters of the moon were originally thought to be the scars of extinct volcanoes. In fact, we discovered it has been ravaged by more than 300,000 impacts.
The moon and the Earth are very similar distances away from the sun. And so if the moon has been hit by all these asteroids, you know that the Earth's been hit as well.
It happens because the asteroid belt is unstable. The enormous gravitational effect of Jupiter can push the asteroids out of the belt and into eccentric orbits around the Sun, passing the inner planets. It is these near-Earth asteroids that threaten planet Earth.
A normal asteroid will be orbiting beyond Mars, between Mars and Jupiter. But if Jupiter perturbs the orbit, it can look like this. And then you get that asteroid moving very much closer to the Sun. And here, the orbit crosses the orbit of the Earth, and so there's a chance of a collision between this object and our planet.
The evidence of impacts on the Earth is now hard to find because the surface has been eroded and reformed over the millennia. But one spectacular crater, perfectly preserved in the dry Arizona desert, was the key to understanding our planet's violent past. Meteor Crater was once thought to be a volcano. But in the 1950s, it became the first impact crater to be positively identified on Earth. Geologist Jay Melosh has pieced together exactly what happened 50,000 years ago, when a small metallic asteroid, 120 feet across, struck the surface.
The projectile here came in at about 20 kilometers a second, much, much faster than a rifle bullet. And instead of penetrating through the rocks, it met the resistance of the rocks, flashed into vapor, and basically exploded.
With the energy of a 20-megaton nuclear bomb, it excavated a crater 2,000 times its own size. The asteroid was almost entirely vaporized.
After the explosion took place, there was a drizzle of iron rain for about within a couple of miles of the crater rim itself.
Only a few small lumps of the iron-nickel asteroid have ever been found. But Meteor Crater is a mere pinprick compared to some. So far, geologists have identified more than 150 major impact sites around the world. But this is a tiny fraction of the total. It's estimated that the Earth must have been hit by over 3 million asteroids and comets. Clever detective work has brought several hidden craters to light, and some of them are monsters. Testament to impacts whose effects would have been truly global. This is Sudbury, Canada. People have lived here for over 100 years, drawn by the rich nickel deposits just below the surface. Then, in the 1960s, it became clear they were living in the middle of one of the largest impact craters on the surface of the Earth, over 125 miles across. But only a few remnants of the crater walls remain, marked by a ring of unique rock formations. Geologist David Kring is a leading expert in identifying impact structures.
Look at this beautiful shadow cone. You got to get a photograph of this. You know, the shock wave for that thing came roaring in from over here, hit some imperfection, and then caused this shearing, shattering of the rock. You know, if you take a microscopic look at this, you can see that it's actually melted along the surface.
These shatter cones are the key evidence that this is the site of an ancient impact crater. They could only have been formed by the incredible forces of a massive collision.
Here at Sudbury, an asteroid maybe 10 to 20 kilometers across slammed into the Earth's surface, and it basically altered the Earth's crust all the way down to the mantle. When it did this, it caused the rock to actually behave more like a fluid, more like toothpaste or water.
The scale of what happened here at Sudbury almost 2 billion years ago is unimaginable. A massive object, 10 miles across, was on a collision course with Earth. The huge asteroid passed the moon at 70,000 miles an hour. It took just 3 hours to reach the Earth. And 3 seconds to smash through the atmosphere. The giant object penetrated over 6 miles below the surface. Billions of tons of rock were vaporized and thrown up into the atmosphere. The shock waves raced round the entire planet, producing 1,000-mile-an-hour winds. Crater walls over a mile high were thrown up. Molten lava was driven up through the Earth's crust by giant seismic waves rebounding off the core. Millions of tons of rock fell back from the sky, creating a flat plateau at the bottom of the crater. An impact on this scale could happen again. And if it does, the effect on the human race will be devastating. Observatories around the world are on the alert, searching the skies for objects capable of causing more damage. The latest count reveals that orbiting within striking distance of Earth are at least 1,000 asteroids half a mile or more across. There are more than 100,000 the size of a football field and 100 million the size of a house. If you could see all the asteroids that are big enough to destroy an entire city, they would outnumber the visible stars. If a near-Earth object should be discovered heading our way, what could we do to avert disaster? There is no international plan on how to defend the Earth against the catastrophe of an impact from space. It's been left to individual scientists to dream up ways of saving the planet.
Deflecting an asteroid is not as easy as it might seem. One of the means of deflecting asteroids that most people think about is a nuclear explosion. The trouble with that is you only blow it up into pieces that are now radioactive and that will still fall in the same place.
A safer plan may be to change the orbit of the asteroid by using rockets to push it off course. Or by towing it with solar sails powered by radiation from the sun. Jay Melosh has another remarkable idea.
Another approach using the sun's energy is to focus sunlight on the asteroid, heat up a spot so that the rock starts vaporizing. And due to the reaction of that vapor, the asteroid will slowly move out of collision course with the Earth.
In space, a giant curved mirror would be used to focus the sunlight. In the far future, an even more ingenious solution may be possible.
Hey, imagine this rock I'm sitting on is an asteroid. One way of moving it is to mine a piece of it, pick it up, and throw it off at high speed. That thrust gives me a little bit of motion in the opposite direction. Then if I pick up another rock and throw that off, I get another slight impulse in that direction. And if I keep throwing rocks one after the other, after the other, after the other, rock after rock, I can drive my asteroid out of collision course with the Earth.
Changing the orbit of a giant asteroid hurtling through space may sound like an impossible task. But we've already taken the first step. Our exploration of near-Earth asteroids began in 1996 with the launch of a very special space mission. Five years later, in February 2001, came the climax of the mission. It was the most significant landmark in the exploration of space since the moon landing. Mastermind behind the project was Bob Farquhar.
I gotta go meet some people in here.
It's much easier to land humans on a near-Earth asteroid than it is to land them on the surface of the moon. Even though they're further away, there's virtually no gravity, and so it's very easy then to reach the surface.
Bob Farquhar had been commissioned by NASA to design a series of low-cost missions to comets and asteroids. For his planned asteroid rendezvous, his probe was sent speeding on its journey by a series of ingenious slingshot orbits around Earth. Farquhar's target was Eros, a 21-mile-long asteroid. These radar images were all they knew about their destination. In February 2000, the probe finally went into orbit around Eros. Over the next year, the probe transmitted back over 1 million high-resolution images. With the primary mission objectives safely achieved, Farquhar wanted to go one step further and land on Eros.
We had an opportunity to do something that nobody had ever done before, so why not do it? We've already had a very successful mission. It would be crazy not to do it.
Farquhar was attempting a maneuver that his spacecraft had never been designed to do.
First of all, we didn't have any landing legs. That was one problem. The other problem was that we were almost out of fuel on the spacecraft. We weren't sure if we would have enough fuel to break the fall on the way down.
Even if the probe crashed, the team hoped to record high-resolution images during the descent.
In order to take pictures of the surface, we have to come down to where the camera is pointing down while we're keeping the antenna on the Earth and the solar panels on the sun. So all three of these things had to be done at the same time.
At 6 p.m. on the 12th of February 2001, the descent began. On the way down, the probe sent back 69 images, the most detailed ever seen of an asteroid. 8 p.m., the probe touched down. Farquhar's team had achieved the softest robotic landing in space history. The success of this mission gives us hope of reaching a rogue asteroid and deflecting it from a collision course with Earth. The orbit of Eros is stable and poses no immediate threat. But out there are millions more asteroids. There's a continuing threat from objects falling from space. There are reminders every day when small asteroids called meteorites enter and burn up in the Earth's atmosphere. These fragments were captured on camera in the night sky over Langley, Virginia in the United States. This large meteorite passed over the Rockies in 1972. It skimmed through the upper atmosphere before bouncing back into space. Had it landed, it might have destroyed a town or a city. One of the worst reminders of the dangers we face happened in Tunguska in Siberia in 1908. An object 200 feet across exploded 5 miles above the ground, devastating over 1,000 square miles. It may have been a near-Earth asteroid, or it might have been a comet. We still don't know. Unlike asteroids, comets are made mostly of ice and dust. They announce their arrival in spectacular fashion with a huge trail of vapor. Among recent visitors to the inner solar system are comet Hyakutake in 1996 and comet Hale-Bopp in 1997. Throughout history, comets have been regarded with fear and awe. Then, in the 17th century, Edmund Halley established that comets were solar system objects circling the sun on long elliptical orbits. He correctly predicted that the comet we now call Halley's Comet orbits the sun every 76 years, passing Earth each time. Most famously, it appears in the Bayeux Tapestry of 1066. In 1986, on its most recent visit, the world's space agencies were ready to meet it. The European space probe Giotto flew to within 400 miles of the nucleus and captured these spectacular pictures.
The European Space Agency didn't just sit back and ignore this comet, it actually went there. And I was very fortunate to be on the camera team, and so I was on that group of people who took the first picture ever taken of the nucleus of a comet. Comets are pristine. They haven't been messed about with. You're seeing something that's been in deep freeze for 4,500 million years.
Comets, like asteroids, are leftover debris from the formation of the solar system. A hailstorm of ice and dust was violently flung outwards by the gravity of the newborn planets. Far beyond the solar system, a vast cloud of ice now stretches out 6 trillion miles, a quarter of the way to the nearest star. Known as the Oort cloud, it envelops our entire solar system. Each lump of the Oort cloud is a dormant comet. There are more than 1 trillion of them, over a mile across. They drift so slowly, they take 30 million years to orbit the sun. But as our solar system moves through space, the gravitational effect of neighboring stars changes, and this disturbs the equilibrium of the Oort cloud, sending a few comets on journeys towards the sun and the inner planets. Halley's Comet began its voyage 2 million years ago, as the first humans walked the Earth. The comet took 1 million years to reach the orbit of Neptune. Out here, it was still invisible, a dormant lump of ice, coated with a dark layer of dust and dirt. Slowly, a transformation began. There was enough heat from the sun to melt some of the ice. Cracks began to form, and vapor and dust escaped from the frozen nucleus. The solar wind, a stream of charged particles from the sun, blew the dusty vapor into a tail. As it passed Jupiter, the comet tail grew longer. By the time it was visible to the naked eye on Earth, the tail was millions of miles long. Halley's Comet will continue to orbit the sun until all its ice has melted.
I've worked it out. It's got about 3,000 orbits left. 250,000 years into the future, Halley's Comet will be no more. All that you will see is this great big sausage of dust around its orbit.
As we orbit the sun, Earth passes through the tail of several comets. The comet particles burn up and glow as they fall through the Earth's atmosphere. Some cometary particles survive their journey through the Earth's atmosphere and settle on the ground. Thousands of tons of this cosmic dust reaches the surface of our planet every year. We touch it, eat it, and breathe it every day. And now it seems this dust may have played a truly remarkable role in Earth's early history, the creation of life. Our planet took shape over 4.5 billion years ago. For the next 700 million years, the Earth and the Moon were bombarded by swarms of asteroids and comets. The young Earth was a hellish environment where the fragile ingredients for life could not have survived. At the Natural History Museum in London, this scientist is researching the revolutionary idea that the ingredients for life were brought to Earth from outer space. Matthew Genge is an expert on cosmic dust.
Cosmic dust can survive coming through the Earth's atmosphere. Those particles that are travelling the slowest don't burn up at all and actually reach the Earth's surface where we can collect and study them.
Genge studies cosmic dust collected from unpolluted environments such as the frozen ice cap of Antarctica. Here, scientists collect pure samples of cosmic dust that originate from the formation of the solar system.
The Antarctic is very clean. There's very strong winds blowing away from the poles. If we melt the ice, many of the dust particles we find are from space, they're cosmic dust.
Using an electron microscope, Genge can examine the structure of the dust particles magnified 200,000 times. He can trace back the story of these particles billions of years.
Many of the particles you can tell are extraterrestrial because they have slight signs of being heated in the atmosphere. So this particular particle here, so you can see the rounded shapes. It's ballooned out because bubbles of gas have formed inside it.
Genge has found that many of the particles are rich in carbon compounds, the raw materials of life on Earth.
Some of the carbon they contain is in exactly the right form that life would need to get a head start. So we have complex molecules like amino acids used in proteins and base acids and sugars used in DNA. The picture that's starting to emerge is that the basic building blocks of life could have originated in space, in interstellar space.
Because of the importance of cosmic dust, space missions are being planned to capture pure samples directly from a comet. In 2004, NASA's Stardust space probe will approach Comet Wild 2. The spacecraft is specially designed to collect dust from the comet's tail. It will eventually return the samples to Earth for analysis. If cosmic dust did bring the ingredients of life to Earth, a mystery remains. Where, amidst the violence of the early Earth, did the fragile materials survive? Early Earth was a dangerous place, constantly bombarded by asteroids and radiation. No one knows how or where the raw materials for life could have evolved into the first primitive living cells. Now, at the bottom of an ancient crater, David Kring has found rocks he believes hold the clue to where life could have originated.
When an impact event occurs, it deposits a tremendous amount of energy in the Earth's crust. That basically manifested in the form of heat. This heat causes water and other fluids in the Earth's crust to circulate. And those systems are exactly the types of system that where prebiotic chemistry can evolve to form life. And in fact, it's the type of environment where the most primitive forms of life on Earth would have actually thrived.
These hydrothermal springs would have been protected in deep fissures, safe from the intense radiation and bombardment at the surface.
This is a sample of the bottom area of the impact crater here at Sudbury, and what this is showing us is a vein that's going through the rock, and this vein was created when fluids flowed through it, producing this lovely lacy texture. These hydrothermal systems may have survived for 100,000 years to perhaps 1,000,000 years, giving ample opportunity for life to evolve in those systems.
Comets and asteroids may have had a vital role in the creation of life on Earth. But the deadly aftermath of huge impacts could also have played a crucial part in the later evolution of life. The evidence can be found all over the globe. On the island of Susha, off the northwest coast of America, an amazing event in the history of our planet is revealed in the layers of rock. Astronomer Don Brownlee has come here with geologist Peter Ward to see the effect of a large impact on Earth's fragile life forms.
What we've learned from the fossil record is extremely important in understanding outer space. There's an awful lot of astronomers who look up, and I really challenge them to look down at their feet, look at the rock record.
So is this just another clam?
Yep.
Huh.
Just another clam, just another totally extinct species that will never be on the Earth again.
That's right.
But just another clam.
That's right.
In these ancient layers of rock, rich in fossil marine life, many of the species suddenly disappear. Here is the evidence of a mass extinction.
So how deep was the water? This shallow water?
Yeah, it's just maybe 50 feet deep or less. In some places we have indications of it being intertidal. So this was a really rich environment community that's totally different than ours today, and it didn't gradually evolve into ours today. It was destroyed, and then ours comes back and picks up the pieces. So this isn't any sort of gradual process. This is bits of space, your stuff coming in, smashing the world, destroying 75% of the species, and leaving us a few dregs that evolve into what we have today.
Sorry, Peter.
You're done.
This is fantastic.
We now know that the impact that wiped out these clams had far-reaching consequences. It destroyed most of life on Earth, including the dinosaurs. The impact happened 65 million years ago at Chicxulub in the Gulf of Mexico. Billions of tons of rock and dust were thrown up high into the atmosphere. A few hours later, giant rocks rained down around the entire planet. Within hours, fires stripped the planet of vegetation. The surface temperature rose hundreds of degrees. The smoke joined the ash thrown up from the impact, and direct sunlight was cut off for years. The temperature soon plummeted. With only a few species able to survive this cosmic winter, the evolution of life suddenly took a new direction. This may not be the only time that an impact changed the direction of evolution.
Impact events, the size of which formed Sudbury, the size of which formed Chicxulub, occur on average every 100 million years. During the period of complex life on Earth, we know we should have had about 5 or 6 impact events of that size. Coincidentally, we had 5 major mass extinction events, and so one of the hypotheses we're exploring was impact events correlated with those extinction events every time.
The fossils of creatures wiped out by mass extinctions over the last 500 million years can be dated by the layers of rock in which they are found. If geologists can match the dates to those of large impacts, then we will know that asteroids and comets have been one of the most important factors in the evolution of life.
In the case of the Chicxulub impact event, what we did was we wiped away the age of dinosaurs and we created the age of mammals. Fortunately for us, because that allowed the human species to eventually evolve.
It's 65 million years since the last great impact. The next one could happen at any time. Astronomers at the Arecibo Observatory are helping us to monitor the threat from space. They are surveying the skies to find out more about these invisible killers. Only radar will accurately reveal their orbits and size. Tonight, Steve Ostro is hoping to get the first images of a newly discovered world, asteroid KW4.
We transmit, and a little more than a half minute later, we start to get the first echoes, and then we receive for that same period. And we go back and forth between transmitting and receiving all night long, building up the echo strength, making images of the object.
At 5 past midnight, Ostro and his team receive their first echo. Now the data must be decoded. At 2 a.m., the first images of KW4 begin to appear.
We see a very large object that's rotating very rapidly. Then we have a secondary object that's smaller and not rotating as fast, and they're in orbit around each other. It's a binary system. A striking result.
Steve Ostro has discovered 2 new worlds. The largest, 3/4 of a mile across, and just 3 million miles from Earth, only 12 times further than the Moon.
We see something on the computer screen, and it's a momentous experience emotionally, because we know that throughout the rest of the future of humanity, these objects are going to play a big role.
Many people believe asteroids are the key to human exploration deeper into space. Robot communities could be dispatched to mine the rich resources. Then there would follow human settlements. Steve Ostro believes he's found several asteroids suitable for colonization.
There are very positive reasons to go to these objects, and that is the resources, the minerals that they're made out of. In particular, life support minerals, which really comes down to water. Water is the key to living the Star Trek fantasy of actually having people in space.
As their host asteroid hurtles through space, these remote human colonies will be carried on amazing journeys around the solar system.
There's millions of these different kinds of places waiting for us to explore them, waiting patiently, but not with infinite patience, because somewhere out there there's an object that is on a collision course with Earth sometime, and we don't know when.
When we do discover an asteroid or comet heading towards Earth, will we be ready to meet it? Could we prevent a collision? We will get just one chance to defend ourselves.